Well, a warm welcome to anyone joining. Thank you for being here. Go ahead and get yourself ready with a notebook. Grab a pencil or a pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have a problem from Algebra 2. That's sort of the level that you would have learned how to do this. Let's move this a bit. And we're dealing with this complex fraction, these rational expressions. The goal of the problem is to simplify this rational expression. So we have a fraction on top of a fraction, and we want to fix that somehow. If you're stepping into pre-calculus, or especially calculus, you need to know how to work with these structures. And if you've forgotten, well, it's time to jog that memory, buddy. So go ahead and give yourself about, let's say 4 minutes. Less than 5 minutes is definitely the goal. But if you can get this done in like 3 minutes, I'd be really impressed. Take the time that you need. See what you remember how to do from this problem. And when you're done giving it a shot on your own, you can unpause the video, come back, see how we did it here. Okay, let's get started. Well, a lot of students want to first fix the top, fix the bottom, sort of separately, and then we have this fraction on top of a fraction. But what I would like to do is I'd actually like to find the least common multiple of all of the denominators that you see, meaning this and this. So out of x plus 2 and 3x plus 6, we want to multiply by something on top and bottom, which will cancel those out completely. And you might notice that 3x plus 6 is really just 3 times x plus 2. So this indeed is the least common multiple, which allows us to use it and multiply the top and bottom of the fraction as such. So we're going to have 6 minus 24 over 3x plus 6. This entire numerator is going to get multiplied by 3 times x plus 2, which is really just 3x plus 6, right? And in the denominator, we're going to do the same thing. So we're going to multiply this 10x squared over x plus 2 minus 4x by 3 parentheses x plus 2. If the least common multiple had more than this factor, like maybe an x plus 1 in there, I would also have to multiply by that on top and bottom, just to cancel one of the denominators. We want to make sure that we're multiplying by the least common multiple, which is going to have exactly what we need to cancel out. Okay, let's get started, because if we distribute this, we know that it's going to cancel out the 3x plus 6 on one hand, but for the 6, we still have to multiply this. 6 times 3 times x plus 2 minus 24. And on the bottom, when we multiply this with the distributive property, the x plus 2 is going to cancel, but we're still left with a 3. So this is going to be 10x squared still times 3 and minus 4x times the whole thing, 3 times x plus 2. All right, so let's work this out a little bit. It's coming out pretty nicely already. We're going to have 18 times x plus 2. That's going to give us 18x plus 36 and minus 24 on top. And then on the bottom, we're going to end up with 30x squared minus, let's do this carefully. So 3 times x plus 2, of course, that gives us 3x plus 6. And let's multiply the 4x to that. That's going to give us negative 12x squared and negative 24x, isn't it? So when we simplify, we have some pretty nice expressions left over. Here's 18x squared, minus 24x on the bottom. And this absolutely simplifies even further. I can take out a 6 from the top, leaving me with 3x plus 2. On the bottom, I can do a couple of things here. I can divide out the x, but I can also take out a 6. So here's 6x, leaving us with 3x minus 4. And if we cancel the 6's, we get a nice simplified result of 3x plus 2 over x times 3x minus 4. If you'd like, you can leave it like that, or you can call it 3x squared minus 4x. It doesn't really matter, but a lot of times they want you to factor it completely, so maybe we'll just leave it in factor form. Okay, that's all there is to it. So with these complex fractions, it really is a good idea to just eliminate all of the denominators in one fell swoop. You want to multiply the entire numerator and the entire denominator by something that's going to get rid of all of the fractions, the mini fractions that exist in the top and in the bottom. And if you can do that, then you just end up with some polynomials on top and bottom. It might be linear. In this case, we have a linear numerator as the result and a quadratic denominator as the result. All right, that was some good, clean fun. I hope it reminded you of how to work with these rational expressions, especially complex rational expressions. And I think that's enough blab out of me. I'll see you guys next time.